This is Guided Practice 10. We're working with 7.1 integration by parts. We've got a couple of integrals here to solve. So we're starting with number 1 where I've got x times e to the x over 5. And I'm going to, like always, make my u the polynomial. So u is going to be equal to x. That means that my dv for this one is going to be e to the x over 5 dx. My du is dx. And my v is, okay, now be a little bit careful here. This is a baby u sub. Okay, so if I'm going off to the side here and zooming in, if I'm going to write all this out, I'm going to have a baby u, which I'm going to call, let's call it r. I'm going to call that x over 5, right? And that's because dr is 1/5 dx, right? So then if I'm taking the antiderivative of e to the x over 5, then that is integral of e to the u times 5 dx, right? Because what I'm going to do in here is multiply both sides by 5. So this is 5 dr. And so this should be 5 dr, not 5 dx. So my dx is 5 dr. And so this is 5 times the integral of e to the not u, but r. So this is 5 times integral of e to the r dr, which is just 5 e to the r, which is 5 e to the 1 over 5, right? If you remember with baby u sub, you take the integral of the antiderivative of whatever the function is, and you divide by whatever the multiplier by x is. In this case, the multiplier of x is 1/5, and when you divide with it, you flip it over and multiply by 5. X over 5. So that means, after all that the antiderivative of e to the x over 5 is 5 e to the x over 5. Okay, and you can check it if you take the derivative. That's just e to the x over 5 times the derivative of the exponent, which is 1/5, and it cancels out the 5. Get you right back to where you started. Okay, from here, we're using our integration by parts. So we're 5 times x times e to the x over 5 minus the integral of these two, 5e to the x over 5 dx. Okay. We get 5x e to the x over 5 minus, pull the 5 out front, and we're taking the integral of e to the x over 5. We did that already. We know what the antiderivative of e to the x over 5 is. So we have 5x e to the x over 5 minus 5 times the antiderivative of e to the x over 5 we know is 5 e to the x over 5. And we're going to add on a plus c because this is our indefinite integral. And then I'm just going to simplify and multiply those 5s to get minus 25 e to the x over 5 plus a constant. And there's number 1. Okay. Number 2, we've got t squared sine 5t. Okay, let's start with u is going to be our t squared because that's the polynomial. And our dv is the sine of 5t dt. Our du is 2t dt. Now I need the antiderivative here of sine of 5t. Again, baby u sub because I have something that's a number times t in there. So we'll go to the side and do it again. So if I'm thinking, what's the integral of sine 5t dt, then I'm thinking, oh, I would sub for 5t, and the du would be 5 dt, and we would make it the integral, and we would make this dt equals 1/5 du, and we would make it the integral of sine of 5t becomes sine of u. And the dt is 1/5, which I'm going to put out front, du. Antiderivative of sine u is negative cosine u. So we get negative 1/5 cosine u. Plug our 5t back in. Negative 1/5 cosine 5t. And again, that's a baby u sub because the antiderivative of sine is negative cosine, but you divide by the number multiplying your variable. So we're dividing by 5 or multiplying by 1/5. So that tells me that my antiderivative for sine 5t is negative 1/5 cosine 5t. That we use in our integration by parts. So this becomes negative 1/5 t squared cosine of 5t minus the integral of, all right, now we're taking these two together here and here. So 2 times negative 1/5 becomes negative 2/5, and I'm going to put that out front. T times the cosine of 5t dt. That simplifies to negative 1/5 t squared cosine 5t plus 2/5 integral of t cosine of 5t dt. Okay, great. Except now we have to take the integral of two things multiplied together. So that means we're going integration by parts again. So I'm going to change, set my u to be the t again because that's my polynomial. And my dv is the cosine of 5t dt. du is dt. And my v is going to be antiderivative of cosine is sine, keep the 5t, and then we divide by the number in front of the t, so that's the 1/5. Okay, so that's a baby u sub, which you should start to get used to doing without having to write everything out. If you've got to write everything out, it looks something like this. Right, you're taking the integral of cosine of 5t dt. Your u is the 5t, so you have du is 5 dt, or dt is 1/5 du. So you're finding the integral, 1/5, the integral of cosine of u du. That's 1/5 times negative sine of u, which is 1/5 the sine of 5t, which is exactly, except I did this wrong. This shouldn't be negative, right? Antiderivative of cosine is positive sine. I want to keep my positives. Okay, so that's how I get my 1/5 sine 5t. All right, back over here. We've got negative 1/5 t squared cosine 5t from above plus 2/5 times. Now, the second integral, we're using the integration by parts here. So that's going to be these two multiplied together. So 1/5 t sine of 5t minus the integral of 1/5 sine 5t dt. Okay, this is negative 1/5 t squared cosine 5t plus 2/25 t sine of 5t. Now I'm distributing this 2/5 to here and to here. So that's going to be 2/5 times negative 1/5 is minus 2/25 integral sine 5t dt. And that's another baby u sub, negative 1/5 t squared cosine 5t plus 2/25 t sine 5t minus 2/25 times. Now, antiderivative of sine would be negative cosine 5t, but the 5 in front of the t has to come out as a 1/5 and add my plus c to that. And you can go ahead and distribute that. I'm running out of space, but I might be able to sneak it in here. This is negative 1/5 t squared cosine 5t plus 2/25 t sine of 5t plus 2/125 cosine of 5t plus a constant. You'll notice there's some structure to this, right? We go from t squared to t to nothing. And we go from cosine to sine to cosine. It bounces back and forth sine-wise with your trig functions. Okay. That's number 2. Number 3, how many do we have total? I think we have 6, right? Yes. So I think I'll do the first 4, and then I'll take a break and put it at the other 2 in a second video. All right. let's talk about arcsine. So for arcsine is going to be similar to our arctangent and our natural log. So when we go to use our integration by parts, we're going to let our u be our arcsine, because if I knew what the antiderivative of, I would just do it. Your dv then here is dx, which means that v is x. Du, we need the derivative of arcsine. And the derivative of arcsine is 1 over the square root of 1 minus x squared dx. So when we use our integration by parts, we get the diagonal, which is x arcsine x, minus the integral of x over square root 1 minus x squared dx. Now, in order to do this integral, we're going to use a u sub. So our u equals 1 minus x squared, what's underneath the square root in the denominator. Then du is negative 2x dx. Now I have the x dx, so let's divide the negative 2 to the other side. And that's going to give us x arcsine x minus the integral of, let's see, 1 over square root of u times negative 1/2 du. And that's plus 1/2 integral u to the negative 1/2 du. That gives us x arcsine x. All right, now increase the exponent by 1, takes us to u to the 1/2 times 2. And so the 1/2 times 2 goes away. And we're going to add a constant on there. And then we want to sub back in for our u. So this is, our u was 1 minus x squared with a square root plus a constant. All right, number 4. Oh, here's all of number 3. So there you go. It's a by parts and a u sub. For number 4, this is a definite integral, so we're going to make sure we get our answer to be a number at the end. I'm going to choose my u to be the polynomial, so the x squared minus 1. So du is 2x dx. That means that my dv is e to the minus x dx. Antiderivative here, again, baby u sub, that negative pops out. We get negative e to the negative x. Okay, so by parts means we put this all together. So negative e to the negative x times x squared minus 1, evaluated from 0 to 1, minus the integral from 0 to 1 of the two bottom ones, negative, so make that positive, 2x e to the minus x dx. Okay. All right, now for this integral, this is again an x times an e to the x, so we need another integration by parts. So our u is going to be the 2x. Derivative is just 2 dx. The dv, by the way, you could pull the 2 out and just make your u x if you'd like. That's fine too. That means dv is e to the negative x dx. We just did this one where it's negative e to the negative x. And so we get e to the negative x times 1 minus x squared from 0 to 1. Notice I distributed the negative inside. Plus, this is going to be negative 2x e to the minus x is along the diagonal, minus the integral from 0 to 1, and this is evaluated from 0 to 1. Let's see, across the bottom, negative, so make this positive, 2 e to the negative x dx. And that one we know the answer to do, too. So this is e to the minus x, 1 minus x squared from 0 to 1, minus 2x e to the negative x from 0 to 1. And this will become 2 times negative e to the negative x from 0 to 1. So let's see, if we plug in 1, that's e to the minus 1 times 0 minus e to the 0 is 1 times 1 minus 0 is 1. When we plug in for 1 here, that's going to be 2e to the negative 1. And when you plug in 0 for the x, that term goes away. In the third one, when you plug in 1, that's going to be negative 2e to the negative 1. And when you plug in 0, that's minus a negative 2. This one is 0. So we have, let's see, negative 4 e to the minus 1 plus 1. And that's my final answer on that one. So 2, integration by parts.